Hi guys, today we're looking at exponential functions or exponential graphs. So the normal form or normal format for these graphs is y. So we will have y is equal to f at x. This is the same as, so in this case we will have px, or we can have something like we can still have a graph of a format y is equal to b to the power x plus q. We can also have y is equal to a b x plus q. Okay, so these are normal format that we can come across if you're looking at exponential graphs. So let's quickly look at some few of them. The only way to look at it, or the other thing to look at it here, let's try to look at some few examples. We might have f at x being equal to, so f at x being equal to, let's say we have f at x equal to, we're looking at 2 to the power x. We can also have an f at or g at x equal to 3 to the power x. We also have h at x equal to 5 to the power x. Let's look at the values of these graphs here. So we can separate it like that. Let's try to separate it like that and see what we can get. So we can have values. Okay, so this is our table. This is normally we have been doing this to sketch the graph. We have been finding the values. Let's say the values of x to be 0, 1, 2, minus 1, minus 2. So we look at f at x when x is 0. When x is 0 at f at x, so we have f at x, but we're looking at f at x to 0, that will be 2 to the power 0, that is giving us 1. So we should have 1. So if we're looking at f at 1 is equal to, f at 1 is 2 to the power 1, that is 2, so f at 1 is 2, and then we can have f at 3, f at 2, so f at 2 will be 2 squared, so f at 2 will be 2 squared, and that will be 4. So same thing if you look at f at minus 1, f at minus 1, f at minus 1 will be 2 to the power minus 1, so that is half. So f at it's half, but f at if you're looking at f at minus 2, this would be nothing but 2 to the power minus 2, and this is the same as 1 over 2 squared, of which is the same as 1 over 4. So this will be 1 over 4. So that is our first sketch or first graph. So let's try to sketch it and see what will happen if we're trying to sketch it. So I think this was bad. Let me try again and sketching it. So let's say we're trying to sketch this graph here, and then you already know that that is our x-axis, so this is our y-axis. So we have our graph, this is our coordinate. You see we're looking at this coordinate here, etc. So we have x is equal to 0 and y is equal to 1, so that one would be here, x is equal to 1 and y is 0. So if x is 1, we're getting y to be 2, so it will be here. If x is 2, we're getting y to be 4, so it's something like that. so vice versa. To see what will happen, this will be our 1, this will be our 2, this will be our 1, 2, 3, 4. Then we can have our minus 1, minus 2. You notice that minus 1 goes as a half, minus 1 is to half, and then minus 2 is 1 over 4. So it will be just a graph like that one. So you see, this will be our function, or this will be our graph, how we sketch it. So basically this is y equal to 2 to the power x, and this is our exponential graph. This is our exponential graph. You notice that it will never reach 0. So if you're looking at domain, or in terms of domain, the domain can be from let's say if you're looking at the domain, our domain will be x. X is an element of real numbers because the domain is defined everywhere in x. But if you're looking at range, our range, you can say that our y is greater than 0. Our y is greater than 0. So meaning that the graph will never come to this negative part of y here. So it will only stay on the positive side. Okay. Suppose we're looking at the next graph of it is g at x. So if you're looking at g at x, we can substitute 0 at x. Maybe we don't need to go through it. Just two. We can just find 2 coordinates. So we already know that at 0 we'll have 1. And then now at 2, or g at 2, g at 2 is equal to the squared of which is 9. So you have 9, and then g, that is g at 2 will be here, will be 9, then will be 3. This one will be 3 because it acts g at 1. So if you put 1 here, you'll get 3 to the power 1. So you can look at it as also, if you're looking at changing this to minus 1, if you put minus 1, it will be 3 to the power minus 1. So it will be 3 to the power minus 1, and that is 1 over 3. So this was 1 over 3. Same thing, we'll have 1 over 9 as well. But already you can see a pattern. If this is 0 because if this is 1 because of 0, that will remain as 1 as well, because you're saying 3 to the power 0. So as you put 1 here, you see you're getting just 3 to the power 1. But if you put 2, you're getting 9. Same thing will happen in the fraction format of it here. You see we have 3, we have 9. So it's the same thing, but this one is becoming fraction. So you can already see the pattern. So let's try to sketch it and see what will happen. Okay, so we have 0 is to 0. So we have 0 is to 1, which is the same point as this one. And now we'll have 1 is to 3. 1 is to 3. Maybe that one would be here. 1 is to 3 should be here. And then we have our 2. Our 2 is to 9. 2 is to 9. Maybe that one would be somewhere here. Okay. And we can also have we're having this point here. So 1 over 3. So negative 1 is to 1 over 3. So that would be maybe that will be here, and the other one will be here. I mean, the graph will look like this, with the same intercept. So it will be just below that one here. It will be below this one, but here it will be above this one. You see, it will be above f at x. So that will be graph G, and this is graph F. So let's try to see if you can see already. If you're looking at this h at x, so h at x will still have 0. We still have 1. We still have 1 because if you put 0 here, you're getting 1. So we have 1, and obviously we will have 5, and we'll have 25 because we look at 5 squared. Same thing will happen here. We'll have 1 over 5, and we'll have 1 over 25. Obviously this graph now will look like something like that one. It will look like something like that. But when you come to this point, as from to 0 to 1, it goes below like that one. You see, it comes below that one. So that will be your graph of age. So your graph of age. So and then clearly you can see what the increase of b does to the graph. As we increase b, and this is our b, you see, if you have y is equal to 2x, our 2 is b. If you have y is equal to 3 to the power x, our 3 is b. So if you have y equal to 5 to the power x, our 5 is b. So you see what happens to the graph if you increase b, or if b increases, the graph is becoming closer and closer. So you see, if the graph if the b decreases, the graph become wider this side of the first quadrant, of which is this one. Okay, so I think that was an introduction to exponential graph, on how we look at it, and how b affect the graph if you increase it, and how it's affected if you decrease it. Thank you so much for watching, and on the next video we will be looking on this second format here, on how q affect the graph, and also on the third one we'll be looking at how a affect the graph of the exponential. So we look at the range already. We're saying that this is our range, and we have our domain here. So we need to see now how q, this is a domain, how q affect the range and the domain, and how a affect the range and a domain, as well as the shape of the graph as well. Thank you so much for watching.